Hi, Karen Carter here again. This week's SOUP presentation covers Chapter 18 of the Web Application Hacker's Handbook, Attacking the Application Server. A web application is dependent on other layers of the OSI stack that support it, to include the network infrastructure, operating system, and the application or web server layer. An attack on a website can be at any one of these three layers. However, the focus of this chapter is at the application server layer from an Internet perspective. Server vulnerabilities that can be exploited fall into two broad categories. They are shortcomings in the server's configuration and security flaws within the application server software. Because software constantly changes, a list of all these defects cannot be comprehensive. However, flaws described in this presentation illustrate the typical pitfalls for any application that implements its own native extensions, modules, APIs, or that reach outside the application container. Due to time constraints, not all of the pitfalls covered in the chapter will be presented. However, my goal for you is to come away with a good understanding of the chapter's overall objective, which is defects in an application server can directly undermine an application's security. This presentation covers those defects. Helpful guidelines are given on how to detect these flaws and how to protect your server from them. Many servers ship with insecure default options, which present potential opportunities for attacks unless they are explicitly hardened. There are some default credentials that are well known and are not required to be changed on installation. The first default option is default credentials. Many out-of-the-box servers contain default credentials that may be publicly accessible. They may be located at a specific location within the web root or may run on different ports such as 8080 or 8443. Table 18.1 shows examples of some of the most common default credentials. Numerous devices such as switches, printers, and wireless access points that have web interfaces also have default credentials out of the box. The displayed URLs list default credentials for a large number of these devices, which anyone can obtain. Exploit frameworks like Metasploit can automate the process of scanning for default credentials by uploading a web archive that contains a backdoor and then executing it to get a command shell on the remote system. Next is default content. The majority of application servers ship with the range of default values and functionality that may be leveraged to attack either the server itself or the main target application. The following are some examples of default content. Administrators use debug as a diagnostic and troubleshooting tool. Debug logs may contain useful information about the runtime state and configuration of the server and the appliance it is running on. Sample functionality is designed to demonstrate certain common tasks. For example, many servers include various sample scripts and pages designed to demonstrate how certain application functions and APIs can be used. For the most part, these scripts are intended to be harmless and should not provide opportunities for an attacker. However, there are two main reasons why this has not been the case. The first is that many sample scripts contain security vulnerabilities that can be exploited to perform actions not intended by the script's authors. Second, many sample scripts implement functionality that is of direct use to an attacker. There is some web server software that contains powerful functionality which is not intended to be used by the public, but can be accessed by the end users through some other means. For instance, some servers allow web archives, also known as WAR files, to deploy over the same HTTP port that is used by the application itself. This process is a prime target for a hacker. Lastly, server manuals may contain useful information that is specific to the installation itself. A good example of powerful default functionality is in the PL/SQL gateway implemented by the Oracle application server. The vulnerability within the PL/SQL gateway is that it provides an interface where web requests are proxied to a back-end Oracle database. Arbitrary parameters can be passed to database procedures using URLs like the one displayed. This functionality provides a means of converting business logic implemented within a database into a user-friendly web application. However, because an attacker can specify an arbitrary procedure, he can exploit the PL/SQL gateway to access powerful functions within the database. An example given is a sys.owa_util.salesprint procedure that can be used to execute arbitrary database queries and therefore retrieve sensitive data. In order to prevent these attacks, Oracle introduced a filter called the PL/SQL exclusion list. This checks the names of the package being accessed and blocks attempts to access any of the packages whose names start with the functions that are displayed. There are tools that are effective at locating default web content. One of these tools is NIC2. NIC2 is an open-source web server scanner that performs comprehensive tests against web servers for multiple items, including over 6,400 potentially dangerous files and CGIs. It also checks for outdated versions of over 1,200 servers and version-specific problems on over 270 servers. It checks for server configuration items such as the presence of multiple index files, HTTP server options, and it will also attempt to identify installed web servers and software. We are finished with default content. Next is directory listings. When a web server receives a request for a directory rather than an actual file, it may respond in one of three ways. It may return a default resource within a directory, such as index.html, or it may return an error such as the HTTP status code 403, which indicates the request is not permitted, or it may return a listing showing the contents of the directory as displayed here. In most cases, directory listings do not have any relevance to security. In fact, they may be displayed intentionally as a means for the user to navigate around sites containing static content. However, there are two main reasons why obtaining directory listings may help in the attack of an application. First, many applications do not enforce proper access control over their functionality, and resources rely on the attacker's ignorance of the URLs used to access sensitive items. Second, files and directories are often unintentionally left within the web root of servers, such as logs, backup files, and old versions of scripts. The real vulnerability is in the failure to control access to sensitive data. Web Distributed Authoring and Versioning, also known as WebDAV, is an extension of the Hypertext Transfer Protocol. It facilitates collaboration between users in editing and managing documents and files that are stored on web servers. HTTP requests use a range of methods other than the standard GET and POST method. WebDAV adds numerous others that are used to manipulate files on the web server. Displayed are some of the methods to look for. The options method is used to list the HTTP methods that are permitted in a particular directory. The displayed response allows several of the powerful methods listed in the previous slide. The put method is very dangerous. If arbitrary files are uploaded to the web root, the first target is to create a backdoor script on the server that will be executed by a server-side module, which will give the attacker full control of the application and perhaps even the web server itself. There is a vulnerability scanning tool for a WebDAV-enabled server, and that is DAVTest. It can be used to iteratively check all directories on the server for the put method and determine which file extensions are allowed. To circumvent restrictions on using put to upload backdoor scripts, the tool also attempts to use put followed by the move method. Page 680 displays the output of a DAV test. Now on to the application server as a proxy. Sometimes a web server is configured to act as a forward or reverse HTTP proxy server. If a web server is configured to be a forward proxy, depending on its configuration, it may be possible to leverage the server to perform various attacks. For instance, the server may be used to attack third-party systems on the Internet, or the proxy server can be used to connect to arbitrary hosts on an organization's internal network. The proxy server may be used to connect back to other services running on the proxy host itself. You can use two main techniques to cause a forward proxy to make forward connections. The first technique is to send an HTTP request containing a full URL, including a host name and optionally a port number. The second technique to leverage a proxy is to use the connect method to specify the target host name and port number. If the server is responding in this way, then it is proxying your connection. The second technique is more powerful because a proxy server simply forwards all traffic sent to and from the specified host. This enables you to tunnel other protocols over the connection and attack non-HTTP-based services. Most proxy servers impose narrow restrictions on the ports that can be reached via the connect method and usually only allow connections on port 443. Securing a web server configuration is not that difficult. Most problems arise through an oversight or lack of awareness, and one that I've added, just pure laziness. There are two important tasks one should adhere to. The first is to understand the documentation for your software. The second is understanding any hardening guides available in relation to it. An excellent hardening guide is one the government uses, the DISA-STIG. The majority of the STIGs are available to the public. I have used these STIGs on the network equipment I manage, and what is great about them is they not only tell you what and how to harden on an appliance or application, but they also explain why you are hardening it. Displayed is a link to the DISA-STIG website. Web server software ranges from the simple, for instance static web pages, to complex platforms that handle a variety of tasks. It is common to think the more complex applications have built-in security. Historically, though, web server software has been subject to a wide range of serious security vulnerabilities, which have resulted in arbitrary code execution, file disclosure, and privilege escalation. However, over the years, mainstream web server platforms have become increasingly robust. In many cases, core functionality has remained static or has even been reduced as vendors have deliberately decreased the default attack surface. Even though these vulnerabilities have decreased, the underlying principles remain valid. Since the first edition of this book, new vulnerabilities have arisen. They are server-side extensions in both IIS and Apache, and newer web servers are being developed from the ground up to support a specific application or one that is supplied as part of a development environment. These are likely to have received less real-world attention from hackers and are more susceptible to the issues we have described. Over the years, there have been some serious defects in web application frameworks. One example is of the padding oracle in the .NET framework. .NET uses PKCS number 5 padding in the CBC block cipher. PKCS is the public key cryptography standard. The book explains how this cipher works and where the vulnerability lies. I'm not going to go into detail on how this works, but if you have taken Dr. Melati's cryptography class, you may actually understand what is happening with this exploit. Public enemy number 1 is the buffer overflow, which is a memory management vulnerability. A buffer overflow allows an attacker to take control of execution in the vulnerable process. Basically, a buffer overflow is when an application copies user-controllable data into a memory buffer that is not large enough to handle it. This results in adjacent memory being overwritten with the user's data. Depending on the nature of the vulnerability, an attacker may be able to exploit it to execute arbitrary code on the server or perform other unauthorized actions. Pages 688 and 689 present samples of buffer overflow, which are displayed here. A good place to start when looking for vulnerabilities in an off-the-shelf product, such as a web server, is to use an automated scanning tool. Automated scanners can be effective at quickly locating low-hanging fruit by sending huge numbers of crafted requests and monitoring for signatures that indicate the presence of a known vulnerability. One such scanning tool we are all familiar with is Nessus. In addition to running scanning tools, you need to perform research on the software you are attacking. Several resources are listed. And always check the exploit database and Metasploit to see if someone else has already done the work for you. The following URL should help you. You should also be aware that some web application products include an open source web server, such as Apache or Jetty, as part of their installation. With these products, performing manual testing and research may be more effective than using an automated scanner. Most organizations that deploy a third-party web server inevitably place its fate in the hands of the software vendor. A security-conscious organization should protect itself against the software vulnerabilities we have just discussed, and this can be done by choosing software with a good track record, apply vendor patches, perform security hardening, and always monitor for new vulnerabilities. You should always use a defense-in-depth approach, implementing layers of protection to mitigate the impact of a security breach within any component of your infrastructure. The chapter closes with the discussion of web application firewalls. In line with the defense-in-depth approach, many web application servers are protected by an external component that either resides on the same host as the application or on a network-based device. These defenses can either perform intrusion prevention or intrusion detection. This concludes my presentation of Chapter 18 from the second edition of the Web Application Hacker's Handbook, Attacking the Application Server.